Alright students, I guess we should start by addressing the elephant in the room. And in this case, I guess the elephant in the room is me. And that's the fact that I'm trying a new software, and so you're going to have to see my face during all these videos. Lucky you, I know. Even more FaceTime with Mr. Schwartz, don't worry. But you can expect to see me on all of our videos now. I attended a conference recently. They turned me on to this new great software, our new website, and to showing myself in my videos. It's supposed to be better. So let's try it out. Today we're talking about multiplying and dividing real numbers, and we're just talking about decimals today. We'll talk about fractions and mixed numbers in the next video, but there's just too much really to do in one video. So we're just going to talk about decimals right now. So here we go. First note, when multiplying decimals, our product needs as many decimal places as our factors combined. So this is just kind of to understand how do we figure out where the decimal goes in our answer when we're multiplying. So you can see in this example, I multiplied 2 and 4 hundredths times 3 tenths, and I just multiplied like normal. And so hopefully you can see this highlighted. 3 times 4 was 12, I carried a 1. 3 times 0 is 0, plus 1 is 1. 3 times 2 is 6. Now, where are we going to put our decimal in that answer? What we have to do is we have to find out how many decimal places are in each of our factors. That first number, 2 and 4 hundredths, has 2 decimal places, and 3 tenths has a 1 number after the decimal. Add those together, our answer needs to have 3 numbers after the decimal place. And we'll talk in class about why this makes sense. It's a little bit of the commutative property and breaking apart these numbers. Now, the second note, when dividing decimals, we swoop the divisor to the wall. We do this in class too. Swoop the divisor to the wall. And then swoop the dividend the same number of places. The final note, don't forget to bring the decimal into your quotient. So you can see in this example, I was dividing 3 and 18 hundredths divided by 6 tenths, but that wasn't good. I didn't know how to think about it in terms of tenths, so I could get a whole number divisor if I swoop that decimal once to the wall. If I swoop the outside decimal, I swoop the inside decimal, and the reason this makes sense is it's kind of like creating equivalent fractions by multiplying both numerator and denominator by 10. We talked about that in class 2. So now we have a new problem that looks a lot easier. 31 and 8 tenths divided by 6. 6 goes into 31 5 times. 6 times 5 is 30. We have 1 left over. Bring down the 8. 6 goes into 18 3 times. So our answer is 5 and 3 tenths. And I know the decimal goes there because it jumps straight up from where it had been between the 1 and the 8 after we swooped. Let's do 2 examples and then I'll set you loose. First one says 3 and 6 tenths times negative 14 and 45 hundredths. The first thing I want to think about is when we're multiplying a negative and a positive, the signs are different, so our answer is negative. Now let's just do this multiplication. 14 and 45 hundredths times 3 and 6 tenths. 6 times 5 is 30. 6 times 4 is 24 plus 3 is 27. 6 times 4 is 24 plus 2 is 26. 6 times 1 is 6 plus 2 is 8. Bring down a placeholder 0 because we're ignoring these decimals to start. So it's kind of like we're multiplying by the tens place now, the 3 in the tens place. So we need that placeholder 0 in the ones place because we're ignoring the decimals to start. 3 times 5 is 15. 3 times 4 is 12 plus 1 is 13. 3 times 4 is 12 plus 1 is 13. And 3 times 1 is 3 plus 1 is 4. We need to add these, so I don't know why that looks like a multiplication symbol. We need to add these and we get 0, 12, 10, 12, 5. Now where does my decimal go? I need to count in the factors. I have 2 decimal places and 1 more decimal place. That's a total of 3 decimal places that my answer should have. So it'll go right there. Negative 52 and 20 thousandths. If you just wanted to say 2 hundredths, that would be the exact same value. Those are equivalent. The same number written 2 ways. 2, you have 48 and 375 thousandths feet of rope that you need to cut into 2 and 1/4 foot pieces. Ugh. How many pieces can you cut? So we need to first let's take some notes to figure out what we have. We have 48 and 375 thousandths. Does anyone have 375 thousandths as a fraction? It's 3/8. And we are going to have pieces that are 2 and 1/4. Uh-oh. Well, now we have a mixed number and we have decimals. If only I could convert so that we all have all decimals are all mixed numbers. So I just told you that 375 thousandths is the same as 3/8, but let's convert 2 and 1/4. That's probably an easier one. 1/4 kind of means like a quarter. So I know that a quarter is worth 25 cents. And we're wondering how many pieces. So let's do some work. Originally, this problem would look like 48 and 375 thousandths divided by 2 and 25 hundredths. Because we're dividing, we're going to take this total amount of rope and split it up into parts. So we need to divide. But we know that we want to swoop this decimal to the wall. That would be 2 moves. So we'll have to swoop it 2 places in the dividend as well. Now this is going to give us some more manageable numbers to work with. 4,837 and 5/10 divided by 225. How many times does 225 go into 483? That would be 2. 2 times 25 is 50. And 2 times 200 is 400. All right, 33 left over. Bring down to 7. How many times does 225 go into 337? Once. 225. Subtract. Get 1,125. What do we think here? Maybe 5? I know that 250 is close to 225, and 250 goes into 1,000 4 times, but we have more than 1,000, and it's smaller than 250. So we're going to try 5. 5 times 5 is 25. I also know the right answer to this. 5 times 2 is 10, plus 2 is 12. 5 times 2 is 10, plus 1 is 11. Okay, so we got it. But we need our decimal. We'll take it straight up. 21 and 5/10, or 21 and a half pieces is how many we'll have. We can have that many pieces. You should write a full sentence. I can't right now because I did so much work. I just don't have any space on your loose leaf. You have space. All right, I'm going to leave you with a couple problems to work on your own. First one, 1,551 divided by 35, or not divided by 35, 1,551 and 35 hundredths divided by 67 and 45 hundredths. Remember what you need to do when dividing decimals. 2, the 100-meter dash is a popular sprint in track and field. If 100 meters is equal to 328 and 84 thousandths feet, how many feet would you run? How many feet would you run if you ran the 100-meter dash 3.5 or 3 5/10 times? Best of luck. I will see you later.